Welcome to Mind Shield. We protect the mind and pursue the truth. Let's get started.
Have you ever heard of a technology that could beam a voice directly into someone's head? A voice that only they can hear, totally silent to everyone else around them. I mean, it sounds like something straight out of a spy movie, right? But what if I told you this very idea has been seriously looked at for decades? Okay, let's dive into this because it's a fascinating and maybe a little unsettling story.
Right off the bat, you need to know this isn't just some fringe science fiction. As this source points out, the concept, which goes by the name voice-to-skull, is scientifically established, at least in a lab. It's all based on a real phenomenon called the microwave auditory effect, which was first reported way back in 1961. And yep, it's been considered for some very real-world military applications.
And this is where it gets really tangible. This isn't just some theory buried in a research paper. The idea was detailed enough, it was novel enough, that it was actually granted an official United States patent. And that patent, well, that's what we're going to break down today.
So let's get right to it. We are talking about U.S. patent number 4877027. This is the document, the blueprint for a system designed to do exactly what we've been talking about.
Okay, so what does that actually mean? The inventor, Wayne Brunken, proposed a method for creating sound inside the head. Not through the ears in the normal way, but by aiming a special beam of high-frequency energy, think microwaves, at a person. The whole idea is that this energy creates a tiny, super rapid heating of the tissue in your head, which in turn creates a pressure wave that your inner ear can actually pick up as sound. Wild, right?
So how would a device like this even work? At least in theory. The patent lays out a kind of step-by-step guide, an electronic chain of events to get from a recorded voice to a sound that someone perceives in their brain.
And here's the process, laid out nice and neat. You start with a radio frequency source, basically a radio wave generator. Then you modulate it, which is a fancy way of saying you stamp an audio pattern onto it, using really short pulses. After that, you gotta amplify it, give it enough juice, and use an antenna to aim it. The beam travels through the air, and if you've aimed it just right, it hits the target's head and creates that perception of sound. On paper, it's a beautifully simple step-by-step process.
So that's the ideal blueprint. But you know, a blueprint is really just a dream on paper until it has to face the real world. And this is where things get complicated. It's time to bring in the laws of physics. This is the million-dollar question for any extraordinary claim like this one. Does the idea actually hold up? Let's take a look at the real-world hurdles, the huge challenges that this hearing system would immediately slam into.
And there are at least 4 massive ones. First, line of sight. These energy beams travel in perfectly straight lines. They can't go through buildings, they can't go through trees, they can't even go through a passing car. Second, attenuation. The signal gets weaker and weaker the farther it travels. The air isn't empty, it actually absorbs and scatters the energy. Third, beam width. The beam just naturally spreads out over distance. Trying to hit a small moving target like a person's head from far away becomes almost impossible. And last but not least, safety. There are strict international guidelines on how much of this energy you can safely expose a person to without causing harm.
You know, a good way to think about it is like a flashlight. Up close, you get that nice, tight, bright circle of light, right? All the energy is focused. But if you shine that same flashlight at a building a mile away, what do you see? A huge dim glow. The beam has spread out so much that the energy is scattered over a massive area. That's a huge problem for delivering power over a long distance.
And when I say a huge problem, I mean astronomical. Analysis of this exact problem has come up with a stunning number. To deliver just a few watts of power to a person's head on the ground from a satellite in orbit, that satellite would need a transmitter operating at the gigawatt level. A gigawatt, that's the output of a large nuclear power plant all focused into one beam. The idea of making that covert or mobile is, well, it's just not plausible.
Okay, so it's incredibly difficult from a physics standpoint. We get it. But let's play devil's advocate for a second. Let's just say someone figured it out and actually built one. What would we look for? What kind of evidence would a device like this leave behind? Because it definitely couldn't be invisible. You'd really be looking for 2 kinds of clues, or signatures. First, you'd look for specific RF signatures. That means looking for very particular pulsed microwave signals, probably on frequencies that aren't used for normal things like Wi-Fi or cell phones. Second, you'd look for environmental indicators. If a really powerful beam is being aimed at a spot, You should be able to measure an RF hotspot and even trace it back to a source direction. You might even see some weird interference with other electronics nearby.
And finding this stuff isn't some black magic. It takes very specific scientific gear and a lot of careful work. You'd need things like broadband RF sensors, spectrum analyzers, and special probes. And the absolute key is taking meticulous, repeatable measurements so you can tell for sure that you've found a real signal, and it isn't just background noise from all the other electronics in our world.
So let's pull all of this together. On one side, we have the patent's really clean, elegant claim. And on the other, we have the messy, difficult constraints of real-world physics and forensics. And this slide really nails the central conflict here. The patent describes this almost magical system, but physical reality comes along and puts up some serious roadblocks. Any real-world version of this would be incredibly hard to build, nearly impossible to aim from any distance, and it would leave a trail of electromagnetic breadcrumbs for anyone with the right tools to find. And this quote from an intelligence analysis pretty much says it all. A patent is not proof that something works. It isn't even proof that it was ever built. It's proof that an idea was described in enough detail to be officially recorded. And when it comes to this particular patent, there's just no public record that it ever went from being a thought experiment to an actual working device.
Now this brings us to a really important idea in science, and just in critical thinking in general, the disconfirmer. See, it's not just about finding evidence to prove something is true. It is just as important, if not more so, to look for evidence that would prove it's false. So if someone were to claim they were the target of a device like this, and careful, scientific measurements showed no unusual RF energy that lined up with their experiences, well, that absence of evidence becomes a powerful piece of evidence itself. It's a disconfirmer.
So what we've really done today is build a kind of toolkit, a checklist you can use to analyze any extraordinary claim. First, you have to really understand the claim. What's actually being proposed? Second, identify the constraints. What laws of physics or nature get in the way? And third, you have to look for the traces. What measurable physical evidence would this thing have to leave behind?
And that leaves us with one final thought. The Patent Office is absolutely filled with brilliant, creative, and sometimes completely impossible ideas. Figuring out which ones are a blueprint for the future and which are just fascinating thought experiments means we have to anchor ourselves in the hard laws of physics and a real, rigorous search for evidence. The question isn't just whether an idea sounds cool, but whether it can actually survive contact with reality.